shot. Okay. So the first part that you had to sort of realize here was that the importance of the gradient point formula. So can you see the paper?
Yeah.
Yeah. Are you familiar with that formula? How that works?
Yeah, I am.
Yeah. Okay. Cool.
But I haven't seen it in that form. I've seen it if y2 minus y1 over x2 minus x1.
Yeah. So that's a bit different. That is just to find the slope of any straight line. So that's where you have. Why can't I click specifically my camera? If everything's off screen, just let me know, because apparently it's not. How do I see if I can quickly change that? Ah, there we go. Cool. So what you're talking about there is the m equals y2 take y1 on x2 take x1. That's for gradient specifically. So the way this one works here is that the y and the x are generic, just like any other y equals mx plus c. So those sort of just stay there as they are. And so basically the way this works is as long as you know the point that your line passes through, or any point that your line passes through, and the gradient, you can figure out the equation of that straight line.
Okay.
And so the reason why that was helpful for us here was because it turned y equals mx plus c, which has a couple of unknown variables, and it allowed us to figure out what c was just by subbing in our y1 and x1, which came from that point 1, negative 2. So fair enough on how we get that first linear?
Yeah, that makes sense to me.
Yeah. So that linear there, right, that's just some generic linear that allows us to... it's a linear that could potentially intersect with our quadratic. And since we're trying to intersect only once, do you remember the criteria for intersecting only once with quadratic?
The discriminant has to be... I can't remember what number, but the discriminant has to be a specific number.
Well, it's similar to how quadratics work in general. Do you know how discriminant works with quadratics just normally?
I've done it a bit, but I'm doing advanced, so I did it last year, a chapter on it. So I'm getting touched with it, but I do know a bit of quadratic.
Yeah, okay. So as far as discriminant works, it's just if your discriminant is greater than 0, you have two solutions. In the context of this, that would mean two intersection points. So it would be like if you had your quadratic and linear did something like this. That's for discriminant greater than 0.
0.
Yeah.
If it's equal to 0, it'll be 1 point. If it's less than 0, it'll have no intersection points.
That's it. Correct? That's exactly right. Yeah. Now the reason that works specifically for this circumstance is because when you take the discriminant, you take it of the equation after you've equated the linear to the quadratic. So we're not really able to take a discriminant of the linear, and if we just did the quadratic, it would tell us the solutions for the quadratic. We want to know the solutions of both, right? These intersection points here are called the solutions to that set of equations. So if you want to only have one, or I think the specific wording was tangent. Tangent just means brushes up against the side of a graph. So yeah, if you ever want to figure out where you have intersection points, the first thing you do is you equate those two equations to each other, which is what this line here was all about. We take our generic quadratic and equate it to this linear that we created above here. From there, the next step is just getting everything to the same side. And then I've just grouped the terms a little bit just to make sure that, well, we know what each term is doing, right? Which one's our A, which one's our B, which one's our C, at least as far as discriminant is concerned. Cool up till then? Yeah. So, for one solution, or tangent, we want discriminant to be equal to 0. So we're just going to grab this this quadratic, the resulting quadratic, and chuck in the B, A, and C terms into the discriminant. That's what these steps are all here about.
Okay, so you just check if the discriminant, making sure it's equal to 0.
Yeah.
That's subbing in points,
That's it. So here's our B term. This thing in brackets here is the C term.
That's our C term.
Yeah. Brilliant. All this is just a bit of simplification there. I take it nothing special is you want me to dig into here?
Yeah, no, I get it,
From here, this one had a pretty nasty solution. You couldn't really factorize this to get anything nice, and so the only real best bet you have here is using the quadratic formula. And so all we're doing is saying, well, okay, there are some solutions m for this, and so we're just going to chuck it into a quadratic because, well, this is a quadratic about m. And so you can use the quadratic formula for that. Simplify quadratic formula, and you get your m values. all you do from there is you say, well, okay, those are the possible gradients for my line. It could be either the positive version of the root or the negative version of the root.
Yeah.
Okay,
that makes
that's pretty much
sense.
it. Yeah. In fact, we can even do a little experiment here now and actually just sort of graph those two things. If my CAS will actually load. Oh no. Decided to reset itself. It's been doing that recently. It's a bit weird. Wonder if the button's just sort of semi-pressed in the back. But basically what we expect would be something to the effect of, if I were to draw a basic axis, we specifically have x squared, and we need to go through 1, -2. So let's say this is 1, this is -2. We would expect something like that, and I mean I've drawn it a bit poorly to do this, but something like that as well. Those will be your two possible tangent lines. Let's find out once this loads up. And yeah, like one succinct way you could write it would just literally be to put the plus minus there in the gradient. You could also write two individual equations, one with the plus, one with the minus. If you really wanted to, you could even go through and expand that out to look like y equals mx plus c. But this is valid as well, and that takes, well, the alternative takes a fair bit of time, so I wouldn't necessarily recommend doing that. Okay, now we can do some gradient, some graphing rather. Let's see, that should be coming up nicely enough. I'm just going to have x squared, and then the second bit. So we're going to have, let's do the positive version first. 2 plus 2 root 3 times bracket x take 1. Whoops. Can I edit? Damn. Minus 2. Okay. Did I type that wrong? 2 plus 2 root 3, x take 1, take 2. Okay. That's a bit blurry, isn't it? There we go, that's a bit better. Okay, so that's one of the possibilities there. Oh, I misread my coordinate when I did the picture. I thought it was -1, -2. That's why it's over this side. So if I draw some relations here, you can see the crossover. If I do...
Yeah, I see that.
Yeah, you see it? Yeah. Just to make it a bit easier, I'll put it in there. So x equals 1, y equals 2.
Yeah, I can see on my CAS as well.
Oh yeah, you got it as well? Nice.
Yeah, I got one, just because my teacher recommended it doing advanced in year 10.
Yep. So you've got this type of CAS, or do you have the...
the blue one, the new one.
Yeah, okay, but it's still this brand, the Ti-nspire.
Yeah,
good.
Ti-nspire.
Yeah, like I recommend getting that one over the Casio by far. It's got a lot of... Like the graphing tool's a lot nicer to use than the Casio. But yeah, and then you could do the exact same thing for the other version of the graph. So that would be the negative version. Bracket 2 minus 2 root 3 times bracket x take 1 take 2. And you should see they both cross over at that point, which sure enough they do.
That makes sense. Thank you so much.
Yeah, no, there's no worries at all. Yeah, that was a bit of an odd one. Usually that sort of stuff would be like a tech active, but I know the book can be a little bit wishy-washy with what it considers tech active and what it considers tech free.
Yeah.
But yeah, that's about it for that question. Was there anything else either for yourself to be answered or from the group that was a bit odd?
I don't have anything.
Easy.
I'm just trying to get myself into method early, so it'll be easier for me later on.
Yeah, absolutely. Yeah, how have you been finding the resources for that so far then? Is there anything I can do to make them better?
Your resources are fine. I just need to get a textbook again. I'll get it back when I go to school.
Oh, yeah, okay, sure.
So I see a textbook that focus on the questions. If I do have any recommendations, I would make practice sheets. That would really help.
Yeah, okay, sure.
I'm stuck doing nothing, watching your videos, which are really helpful, by the way.
Yeah, okay.
That helps me, like,
so you're looking for actual questions to do. So one of the things that's really nice to have is, have you heard of ATAR rocks or VCE rocks?
No.
So I'll put the link in the chat there, and this is really good to hop onto now because it's about to go down. ATAR.rocks. You'll have literally everything you could want, not just for math methods, but for every other subject. It's a file server that has all the textbooks, all of the practice exams, all that sort of stuff. It's there. So literally just Google atar.rocks. Let's in fact I'll check now to make sure it's still up. It said that it was going down like a month ago, and it just hasn't done it yet. If you scroll all the way down, you'll see compressed down.
It says online.
Yeah, so but keep going down and you'll see compressed downloads for VCE.
Yeah, I see that.
Click that and you get, so it's a big file because it's all of the VCE stuff, not just methods, but it'll give you access to the textbook, it'll give you access to all the practice exams, it'll give you access to everything for all of your subjects. So enjoy the cost savings on that while it's still there.
Thanks, man.
Yeah, so that'll definitely help out. That's kind of why there's no worksheets there, because, well, when resources like that exist, it kind of makes it a bit redundant. Unless you think they'd be better than what's in the textbook. What do you think?
I mean, definitely make people more likely to do it.
Yeah, fair enough. Okay, I can pull some like specific examples and get a nice curated thing. Sure. Yeah, fair enough.
Thanks, man.
Sweet. Yeah, I'm happy to help. Yeah. Anything else I can do for you? Or are you happy to just sort of chill? I don't think anyone else will be joining.
I'm happy to chill. So on the question you asked earlier, what I've done so far, I think it was chapter 4, methods, year 11. That was where hyperbola, truncus, all those kind of graphs.
Yep.
The ones above, x squared, x cubed. Is there anything like you should know, like if you're going to go into a test on that? Like what's important to remember?
Yeah, what are the important bits to remember? A lot of it's just on graphing and on being able to determine the rules. So the graphing side of things, I've got all the specific notes on those.
Yeah, I've watched those videos.
Yeah. And then how about the families of functions type stuff? That's when you have to like sort of figure out...
I'm getting a little confused on that part.
Yeah, okay, we can have a look at that then.
Kind of good. Yeah, that'd be great.
Yeah, okay, let's have a look. I'm just going to click through my notes and see if I can find where I've got that. Here we go, families of functions. Okay, so these are the kinds of questions where basically you have some unknown or generic type of function which has like different variables in there, and you're given some information about that function, and then you have to sort of put that information together to figure out what your function is. This one in particular was written in the context of those graphs, so it's like your hyperbola, your truncus, and your square root graph. But this kind of thing exists for everything. It exists for quadratics, it exists for linear, not so much linear, mainly quadratics and basically anything that's non-linear, really.
Yeah.
The through lines for most of it is you're given points along the graph. So anytime you're given a point on that graph, it gives you one possible equation. So the thing you're really looking for here is that the number of unknowns that you have in your equation is the same thing as the number of equations you need to solve those unknowns. So if we're looking at example 1 here, which, by the way, can you see that?
Yeah, I can see that.
Yeah. If we're looking at this example here, we've got an A, we've got a H, we've got a C. So that's 3 coefficients we need to solve for, and that means we have at least 3 pieces of information, or we call those, 3 different equations that we need to solve those unknowns.
Yeah.
In the case of the hyperbola, a lot of the time the information you'll be given is in the context of the asymptotes, whether they tell you that like verbally in the actual as it's written, or they'll give you a graph and they'll say, okay, you can see where the asymptotes are. When it comes to that bit of information, that'll tell you your horizontal and vertical translations, because that's just kind of how the hyperbola and the truncus work.
H and C is...
Yeah, exactly.
Yeah.
So this one we're told vertical asymptote at x equals 3, which means that we now have x minus 3. But since it was already x minus h, we say that h specifically is 3. That's one thing worth reminding yourself on. Knowing the actual form here, x minus h, just because we have x equals 3 doesn't mean that h is negative 3.
It's minus 3.
Yeah.
If it's x plus 3, it'd be minus 3.
It's x plus... Yeah, so being able to, so it's just a matter of saying, h will not necessarily be negative 3 just because x is 3.
Yeah.
You have to look back at where it came from, basically, is all I'm trying to say there. If that said x plus h, then you would say h is negative 3.
Yeah.
That usually only matters for the h term. C is pretty much always a plus.
Always the same,
And so, not have to worry too much about that. But yeah, Once you have those bits of information, at least in this example, all you got to do is sub in the point, and then that allows you to solve the final coefficient. A lot of those are going to follow the same sort of criteria there, and they'll only ever get like different variants of that. You might get some of the crazier questions, kind of like the one we just did to start off with, where it starts branching into other topics or areas of study to try and give you those equations. But basically all you're doing is trying to grab the information that's in the question and compile that down to getting a number of equations to solve those unknowns. Like, one possible solution for the hyperbola, or one possible like question, would just be to give you 3 random points. If you have 3 random points on the curve, you can solve your hyperbola just by doing a 3-way simultaneous on that.
Would you usually do that on paper, or would that give you a CAS?
That would be a CAS. So anything above 2 simultaneous is going to be a CAS. God forbid they give you a 3 simultaneous. Like, well, I say that for exams specifically. I can't necessarily say that for SACs because those are school moderated. So I hope they don't give you stupid stuff like that, because that would be awful.
Could you do that on a CAS? Because I'm not...
Yeah, I can show you how to do it on CAS.
Use a CAS. Yeah,
absolutely. So, how am I going to actually do this now? Because I need to figure out what points actually exist. Okay, let's test some points then. So what I'm going to do is I'm just going to define the function and figure out what points we should use. Okay. I guess before I do that, do you know how to define functions?
No.
Okay. So this will be really helpful because it'll allow you to basically manage a lot of different functions in a test environment. So you're just going to hit Menu, Actions, and then Define. Fair enough?
I don't have that.
If you hit the menu button, which is this one here. Do you have that?
Yeah, there you go, I have it. Yeah, I have that now.
Yep, and then Actions and then Define. Got it?
Yeah, I have that, yeah.
Yeah. Okay, now all we do is define what we want to call the function. So I usually use h of x just because it's in a spot that I know where it is on the keyboard. You know, you've got the alphanumeric keyboard, it's a bit of a pain to use.
Yeah.
So just pick a spot that makes sense to you, and you can use that. And call it, you know, h of x, a of x, whatever you want to call it. Just going to put it in equals, and then you just use you define whatever the function is going to be. In this case, we are a hyperbola, so I'm just going to do 2 over x take 3 plus 1. The advantage of doing that is now all I have to do to figure out some values is just do h bracket whatever, and it'll give me what I need. Fair enough on how that works?
Yeah, that really does help.
Yeah, no, it's really good. And you can be more elaborate with your definitions. You don't have to just call it h. You can call it like, I don't know, wave of x if the function is describing a wave. The reason why that's still okay is because if you hit this VAR button, which is casting a shadow, but it's that there, it'll tell you all of the variables that you've defined. It's technically called a variable as far as the CAS is concerned. So don't feel like you have to limit the number of letters you use because it's painful to type it out. You can always just hit that button and then auto-select it from there. That's helpful in your SAC environments because sometimes you'll have a lot of different functions that you have in the CAS, and you kind of get confused on which one was H, which one was A, and which one was K.
Yeah, that makes sense.
But yeah, so that's that. So let's get a few points just so we can play with it. So h of 1 is going to be 0, h of 2 is -1. Let's say h of -1. What's that? Okay, so those are going to be the points that we're going to use for our 3-way simultaneous. So just to make this work, I'm going to define another function. Let's call it b of x, and it's going to use all the generic terms. So if we had a, x take h. Oh, I can't use h. What are we going to call this now? I don't know. X take d plus c. Cool. That's going to be our 3 unknowns there. Now, for the simultaneous, menu, algebra, or just hit the button 3, solve system of equations, and then again, solve system of equations.
Could you do that one more time?
Yep. So, menu, algebra. Got that? Solve system of equations is number 7.
Yeah.
And then number 1 again, solve system of equations.
Yeah.
Yep, nice. From here, you're just going to set the number of equations. So you're just going to hit left or right, and then press up or down, depending on which direction you want to go.
Yeah.
And then label all of the variables. So I think I was using C and D. So whichever ones you were using, if you're following along, then just use those.
Yeah, where's the comma? Oh, it's over there.
Yeah, it's to the left of the keyboard. Got that?
Yeah, got that.
Okay. Just going to hit enter, and then that's going to populate our simultaneous equation solver. Those three spots are where you put your three equations. So for us, it would be b of -1 equals a half, because that's one of the points we know exists. It would be b of 2 equals -1. And what was the last one? b of 1 equals 0. With any luck, I've set it up right, and it'll give me, those coefficients. So a three-way simultaneous will also work if they give you the worst case scenario, where they just give you random stuff.
Yeah.
Was that easy enough to follow?
Yeah, that was easy enough to follow.
Yeah.
Quite fast. I'm just this.
Yeah, just trying to get used to the layout. Yeah, I understood.
Yeah.
So yeah, one of the things.
Like a couple of days ago.
Yeah, right. So one of the things you can do is use like the numpad here to just sort of click up and down to pre-select stuff you've already done. Like if I wanted to copy this, I would just go up and highlight it, which is just up and down, and hit enter on that. That'll bring it down, and you can then hit enter again to redo it or whatever you need to use it for.
Yeah.
It also works like your regular old computer works. So if you only wanted a specific part of this, like let's say I only wanted to grab the H for whatever reason, I can hold my shift button, which is there.
Yeah.
Highlight it. So if I just hold and go to the right, let's say highlight that, I can do Control and C, just like you would on a
Control C.
Yeah.
And Control V.
Yeah, and it works exactly like you think it does. No one knows that. No one knows that it exists on the CAS.
My teacher taught me that last time. I was so surprised. Like,
yeah, no, it's
brilliant. Do that
brilliant.
for CAS.
Yeah, it's really
like
good.
a mini computer.
Yeah, it genuinely is in more ways than you think. Did you know you can program this?
With a whole different system?
Yeah. Well, I mean, maybe. But you can write code on this.
Yeah, so it says you can do it in Python, Lua, and one more.
Yeah, it's crazy.
Which helps, because I understand both languages.
You what, sorry?
I do both languages. I do Python and Lua.
Python, and what was the other one you said?
Lua. Lua.
Lua. Oh, I'm not sure I remember that one.
It's on the blue one. The black one's not on that. The black one's the basic one, and Python. The new ones come with Lua.
Okay. Yeah, I'm just not familiar with the programming language. Like, I know Python, but Lua. Yeah, okay.
Lua... Have you heard of Roblox?
Did you say Linux?
Roblox.
Oh, Roblox,
It's a game.
Yeah.
Yeah, that uses that programming base as well.
Oh, sure. Yeah, okay. Interesting. Yeah, I thought I was up to date on my programming stuff. I did a engineering degree in it was electronics engineering. We would use a lot of C, C++, and stuff for embedded systems. I'm not sure if you're familiar.
Yeah.
But yeah.
I've heard them, but never learned.
Yeah, no, it's good fun. So you're looking to get into similar stuff in uni?
Yeah, I want to do engineering when I get older.
Any particular engineering?
No, yeah, I'm still confused because there's so many opportunities, like computer, then you've got civil engineering.
Mm-hmm.
They're all different parts.
Yeah. Yeah, it's funny you mentioned those two specifically, because that's what I was tossing up with when I was choosing my degree. I was like, well, I could do civil, I could do something like in the coding space. Yeah, no, that's cool. Yeah.
So what helped you choose?
So when I chose, I started with electrical. I did that at RMIT for 2 years, and then swapped over to electronics, because that was allowing me to do a little bit of electrical, but mostly on the programming side of things.
Yeah.
I worked with these things called FPGAs, which are basically like what you can do is, instead of just programming the chip itself, you can program the actual underlying logic gates on the chip and like physically change the configuration of it, so you can create hardware specific programs. So like are you familiar with like the differences between GPUs and CPUs?
Yeah, a little bit.
Yeah, so they have different. Basically, they have different architecture, right? They're better suited for
Yeah,
different
things.
tasks. The benefit of an FPGA is you can basically turn this generic computer chip into a CPU or into a GPU. You can dynamically boot it to be whatever you want it to be in the for whatever you want on runtime. That was kind of what I was doing.
Cool.
Yeah, so that's a blend of working with electronics and a bit of programming if you're interested in like doing a blend of things. And it's a pretty niche it's a niche thing to get into as well, which is good because when you specialize in something that not a lot of people can do, it's a very highly anticipated skill, or
Yeah.
highly desired skill rather. Like I can say, I went out to Adelaide for my job,
Yeah.
and I was one of two. We called ourselves firmware engineers. I was one of two firmware engineers in the in the building. So it was me as a grad and one other person that had been there for maybe 3 years.
Yeah.
So that, I might recommend that one if you're gonna pursue a role, maybe pick something that's like niche, and that
Yeah.
one's a blend of things, which is quite nice. Yeah, that's a bit of my background, really.
Yeah. Thanks. Well, thank you for helping me out. This was
Yeah.
a great session.
Yeah, so that was just a hyperbola, by the way. The truncus is basically the
Yeah.
same thing. It's asymptotes, usually. Square root is sort of a bit similar. Do you want me to go through the rest of this, or you have somewhere to be?
Yeah. It's I have to go
Yeah,
as
that's
well.
fair. That's fair.
But yeah, I could. This is online. I've seen this before, right? It's
Yeah,
underneath. Yeah.
this is the families of functions. Hang on.
Yeah.
Which one is it specifically? I think I called it MISC functions. Something
Yeah.
like
You
that.
called it MISC. Yeah.
Yeah. It's all here, and I've got recorded stuff as well that's already covering this. And if
Yeah.
that's not good enough, just let me know. I'll tweak it, or I'll give you a message. Anything like
Yeah.
that. Alright,
Thank you so
leave you to it then.
much.
Take care.
Thank you
Appreciate
so
it.
much. This was really good. See you later, man.
Love it. Take care.
Take care.